that rhodopsin has to be regenerated. Okay, after being split, it has to be brought back. It has to be regenerated. So that regeneration is what actually results into what we call dark adaptation. Okay, dark adaptation. So, for example, this dark adaptation actually happens when you don't have more light coming. So that time is taken to regenerate or to resynthesize rhodopsin. And of course, this happens if the trans retinol is converted to cis, and then it is that cis retinol that will actually combine with the opsin to make that rhodopsin. Okay, so during that time, when this is basically what happens, that there is time spent in regenerating the rhodopsin. Okay, so that time is because you want to allow the rods to regain this rhodopsin. Okay, to regain this rhodopsin that has been used before. Okay, and this is the phenomena of what we call dark adaptation, which is that this phenomena allows the rods to adapt to dark environments after exposure to light. When you enter into a dark room, when you have moved from a place or another room that has sufficient light, so there is that time when you can't see clearly until after some few seconds, then now you can see. That is dark adaptation. It's because rhodopsin is being regenerated. That is what we call dark adaptation. Okay, so if we ask you to explain why, if you enter a dim lit room, you tend not to see properly for the first few minutes, and then later your vision actually improves. The reason is because of dark adaptation. So dark adaptation allows rhodopsin to be resynthesized. So what are the key things to do with light perception in the rods? You can call them the characteristics of light perception in the rods. So one is that this rhodopsin breaks down. Okay, after absorbing light, it breaks down into its components. That breakdown of this rhodopsin is very important for the action potential to be generated. But the unique thing is that rhodopsin is resynthesized faster. Rhodopsin is resynthesized faster compared to iodopsin, as we shall see later on. The other very key characteristic about light perception in the rods is the fact that the rods are actually very, very sensitive to light. Okay, why? It is because of what we call retinal convergence, that the rods, the different rods, synapse with at least one bipolar neuron. Okay, this is what we see here. We are having 3 rods that are connected to one bipolar neuron. That is what we call retinal convergence. That means that the overall stimulation of these individual rods is basically summed up they add up such that the excitement is in that one bipolar neuron, and then it will be sent to the brain. That's why they are very, very sensitive. That's why the rods are very sensitive. Okay. And then the cones, for them, you have one cone, you can see this one, connecting to one bipolar neuron. You have one cone connecting to one bipolar neuron. So that means that the cones are not very good in situations where you have little light. So the cones are very good when you have high light intensity. Okay, so the two reasons, the fact that rhodopsin regeneration is very fast compared to iodopsin that we find in the cones, it makes the rods very sensitive, including what we call retinal convergence. But that the concept of retinal convergence can also be, if you find this term here, spatial summation. This is also the same. The concept is basically the same, that the stimulation of these individual rods will basically sum up such that we have an action potential fired through the bipolar neuron. So they are basically related concepts.